Hello Year 9, welcome to the last lesson in this unit on solving equations. Today we will be looking at a method for solving more complicated equations. When we come across an equation we cannot solve using one of our algebraic methods, there are several numerical methods we can use. The one we are going to do today is a decimal search method called trial and improvement. It is a very systematic method and follows a particular set of steps, usually set out in a table. It is not a case of just guessing. It's not trial and error. That's not the same thing at all. I want you to pause the video and have a look at exercise 10G question 1. That's on page 191. I'll give you 2 minutes to think about which of those equations in question 1 that you should be able to solve using an algebraic method and which ones you might need an alternative method for. Hopefully you've identified that equation B is linear, so you can solve it using a method of just inverse undoing it, and equation E is a matter of just taking the square root, which means that equations A, C, D and F need an alternative way of solving them. So let's have a look at some examples. This example here is not in the textbook. There's a couple of extras that I've stuck in that aren't in the textbook, so this is one of those. So use a method of trial and improvement to find the exact solution for x cubed minus 9x is equal to 280. So we need to find a value of x which satisfies this equation, and because it says it's an exact value, this is one that won't have to be rounded. So here is my table. I'm going to put my chosen values for x in the left hand column. Here I'm going to write in what those values give me in the expression x cubed minus 9x, and here I'm going to look at how they compare with what they need to be, which is 280. So I'm going to start with a value of 5. Substitute this value of 5 into here and I get 80, which is too low. So choose another value. I'm choosing x as 10, which when I've substituted in gives me 910, which of course is too high. But it tells me that my value of x is between 5 and 10. So choose a different one. I choose 6, which is 162 when I substitute in, which is too low. I'm going to choose 8, which is 440, which is too high. Which still, you can see I'm narrowing down the interval which contains my value for x. I now know it comes between 6 and 8. So try 7, and that gives me 280 when I substitute it in, which is exactly what I want. So my final answer is x is equal to 7. Always write down your answer at the end underneath the table. Now I want you to pause the video for 10 minutes and have a go at questions 2A, 2C and 2F. Just do those because this is quite a time consuming, this method of solving equations is quite time consuming, so just do those 3. Make sure you use a table and that you set out your steps in a systematic way like this. Hopefully you've done those and checked your answers with the answer sheet. Let's continue. This is an example that is in the textbook on page 190. But it says use trial and improvement to solve x squared plus x equals 48, giving your answer to 1 decimal place. That means we are now starting to solve equations which do not have exact answers, and we can use this method of trial and improvement in the same way. There's a very specific way of doing this. It starts in the same way, so I choose my value of x. I'm going to work out x squared plus x, and I'm going to compare my answer with 48. So starting with whole numbers, I choose x is equal to 6, and when I substitute it into this, 6 squared plus 6 is equal to 42, which is too low. It's not that far off though, so I'm going to choose 7. 7 squared plus 7 is 56, which is too high. So I know my value for x is between 6 and 7. So think of a number line. It's between 6 and 7. I'm going to start thinking of values to one decimal place. Now, first of all, I've identified two consecutive whole numbers. I now need to look at values of x to one decimal place and find two consecutive ones for that as well. So I'm going to try x is 6.3. Substituting it in, 6.3 squared plus 6.3 gives me 45.99, which is too low. So 6.4, when I put it in, will give me 47.36, which is still too low. So 6.5, which gives me 48.75, which is too high. So now I have identified that it is between 6.4 and 6.5. So narrowing down, so we know it's in here, 6.4 and 6.5. It's somewhere in there. Now it is not enough to say that actually 6.4 is closest to it. It's closer than 6.5 because 47.36 is closer than 48.75. You've actually got to show it properly. So the one value in here which will determine whether it rounds to 6.4 or 6.5 is going to be this one in the middle. So you always check this value in the middle. So I'm going to check 6.45. If I substitute 6.45 in, I get 48.0525, which is too high. So considering my number line again, 6.4, 6.5 and 6.45, that was too low, this one is too high, so we know it's in here, and any value in there rounds to 6.4. So your answer is x is equal to 6.4 to one decimal place. Now it's this value here that you are identifying to one decimal place. Quite often people make a mistake and try to get 48 to be as near as possible one decimal place, which is not correct. You're solving the equation. Remember, your equation is in terms of x, you're finding a value for x. So pause the video and try questions 3b and 3e only, using this table method, and again about 10 minutes. Welcome back. Make sure you've checked your answers before we continue. So this is another example that's not in the book. It is possible to continue this method of decimal search, narrowing it down to find values for x to 2 and 3 and 4 decimal places or even more, but it becomes very time consuming. So I am going to do an example which is like the ones that are in question 4, but you won't need to do any of question 4. I'll just show you how the method continues. So I've got x to the power of 4. So the first column is my values for x, x to the power of 4 plus 2x, and I want it to equal 508. So it starts in exactly the same way. I'm looking for two consecutive whole numbers. So I'm going to choose x is 4, x to the power of 4 plus 2x is equal to 264, which is too low. So I choose x as 5, x to 5 to the power of 4 plus 2 lots of 5 is 635, which is too high. So I've now got my consecutive whole numbers. I know I'm looking for values of x between 4 and 5. So I think I'll try 4.8. Now if you're using, well, you will be using your calculator. When you are using your calculators, you can use the edit mode. It's not going to be easy to see on this, I don't think. But it is possible, yeah. It is possible to use, let's see, 4 to the power of 4, take away 2 lots of 4, use your brackets, it's 200 and, looks like I've made a mistake. That's 248. Better check my other one. So use the edit keys to go along and just delete and replace with your new value for x. 615. I have made a mistake. But it's still values between 4 and 5 I'm looking at. So continuing, I'll check my numbers as I go. X is 4.8, should give me which is 2. Now I have worked these out before, so I have just double checked them, so I know I'm right. So let's continue going. 4.6. Substitute that in, I get 456.945 ... because that's the number just carries on going, which is too low. So let's try 4.7. Remember, I'm looking for consecutive numbers here. So that would be 497.368 ... which again is too low. So I knew I had to be between 4 and 5. And now I've got here 4.7 is too low, and the next number along the number line when looking in one decimal places, 4.8, is too high. So I know it's between 4.7 and 4.8. But I'm not looking for numbers to one decimal place, I'm looking for numbers to two decimal places. So let's carry on. I now need consecutive two decimal place numbers. So 4.72 is 505.76, which is too low. 4.73 is 510.0066, which is too high. So I now have my consecutive two decimal place numbers. I know it's between 4.72 and 4.73. So it's going to be, your answer will either be x is 4.72 or x is 4.73. And in order to work out which one, we need to test that one in the middle, 4.725. So test 4.725, which is 507.88 ... which is too low. So considering that interval, 4.72, 4.73, I've tested 4.725, that is too low, that is too high, so my answer is in here, which means everything in here rounds to 4.73, so x is equal to 4.73 to two decimal places. So you can see how this starts to get really long. If you had to work out to three decimal places, you would have had to carry on doing this. So choosing three decimal places between that, and as I said, it's very time consuming. So you don't need to do any of question 4. Our last example is a problem solving one. So this one is also in the book. So we have our problem solving question here. We've got a cuboid with a volume of 392 and we need to know how long is each side. If I want to work out how long each side is, I need to know the length x. And at the moment, all I've got is the information that the volume is 392. So the volume of a cuboid is the length times the width times the height, which in our case, we know the volume is 392, so x times x times x plus 1. So x squared lots of x plus 1, and x cubed plus x squared is 392. And that's the equation I want to solve. It's a cubic equation, it's not one of your standard, you're not going to be able to use one of your standard methods, so we'll use a method of trial and improvement. I need to find the value of x because I'm solving this equation. So I'm going to substitute values of x into x cubed plus x squared, and I want to make 392. So let's choose a value. I'm going to choose 5. 5 cubed plus 5 squared is 150, which is too low. I'm not going to bother going all the way up to 10 because 10 cubed is 1,000, which is way too big. So let's go for 8. 8 cubed plus 8 squared is 576, which is too high. So I want something in between 5 and 8. I'm going to choose 7. Substitute in 7 cubed plus 7 squared is 392, which is our correct value. Notice here it doesn't give you any information about rounding or giving your value answer to x to one decimal place. So I think it's fair to assume that it's likely to be a whole number. So we now know that x is equal to 7. So we've answered like our trial and improvement, solved that equation using trial and improvement like we have before. But we haven't answered the question because the question said how long is each side. So if x is 7, you can write down, so the cuboid measures 7 centimeters by 7 centimeters by, so that's 7 by 7 by 7 plus 1, so 7 by 7 by 8 centimeters. Okay, so Now I'd have you to finish off, so if you want to spend the rest of the lesson time on the problem solving questions, questions 5, 6 and 7 only, please. Well, thank you. Till next time.